Programming languages have shaped the technology landscape, transforming abstract ideas into powerful executable code. From early efforts that translated complex concepts into symbolic representations to the sophisticated specialized languages we have today, programming languages have continuously adapted to meet the ever-growing needs of computing. Across time, we've seen languages that change the way people interact with technology, solve problems, and create new possibilities. Each era brought fresh approaches, innovations, and paradigms, enabling developers to build systems and applications that influence our everyday lives. This journey through programming language history reveals not only the technical advancements, but also the ingenuity and vision that have guided programming forward, one line of code at a time. Our journey begins in the 1940s, where the concept of programming was just taking shape alongside the earliest computers. In 1943, German engineer Konrad Zuse created Plankalkül, a pioneering language intended for engineering calculations. Although it wasn't widely used at the time, Plankalkül was revolutionary. It was the first high-level programming language, proposing symbols and structures beyond the machine code that was common. Zuse's work laid a foundation, envisioning a future where code could operate on a higher level than pure machine instructions. Just a few years later, in 1949, assembly language was introduced, marking a major advancement. Unlike machine code, which relies on binary, assembly language used symbolic codes, or mnemonics, to represent basic instructions. This made programming more manageable and allowed developers to write code that was a step closer to human language, while still directly controlling the hardware. These developments in the 1940s created the earliest tools for programming, setting the stage for the first high-level languages that would come in the following decade. As we step into the 1950s, we see the emergence of high-level languages designed to streamline programming, making it more efficient and accessible. In 1952, Autocode was introduced as one of the first compiled languages, which was a big leap forward. Compilers allowed programs to be automatically translated into machine code, removing the tedious process of hand-coding every instruction in assembly or binary. This shift made coding more practical, especially as computers became more widely used in various fields. Then in 1957, IBM developed FORTRAN, short for formula translation. FORTRAN was groundbreaking. It was the first high-level language to gain widespread use, especially in scientific and engineering communities. With its ability to handle complex calculations and mathematical formulas, FORTRAN became the go-to language for researchers and scientists. In 1958, John McCarthy introduced Lisp, which focused on symbolic computation rather than numerical processing. This made Lisp uniquely suited for artificial intelligence research, giving scientists a tool to work with lists and symbolic expressions. Lisp became and still is a foundational language in AI. The decade closed with COBOL in 1959, developed specifically for business and administrative purposes. Unlike Fortran's focus on scientific applications, COBOL, or Common Business-Oriented Language, was designed for data processing, handling records, and managing business logic. It allowed organizations to process large amounts of data efficiently, shaping business computing for decades to come. The languages of the 1950s each had specific strengths and purposes, creating a diversified toolkit for programming that would continue to expand in the years ahead. The 1960s marked an important shift in programming as languages began to cater not only to specialists, but also to a wider audience and more diverse applications. In 1964, BASIC, or Beginner's All-Purpose Symbolic Instruction Code, was developed. BASIC was a game changer. Designed to be simple and easy to learn, it opened up programming to students and beginners, making it possible for a broader audience to understand and write code. BASIC played a major role in making programming more accessible and fueled the rise of personal computing in the years to come. Next, in 1965, a language called Simula was developed in Norway. Simula was groundbreaking for its introduction of object-oriented programming concepts, especially the use of classes and objects. By organizing code into reusable modules that could represent real-world entities, Simula paved the way for more structured and manageable programs. This concept of objects would later become fundamental in many modern languages. As the decade came to a close, Ken Thompson introduced B in 1969, which was an important step toward creating the C language. B was designed for system programming, particularly for Unix development, and provided a powerful, low-level tool that helped programmers manage complex tasks directly on the operating system. It set the foundation for C, which would later become one of the most influential languages in programming. The languages of the 1960s, from BASIC's accessibility to Simula's structure and B's power, expanded programming's reach and adaptability. This decade laid the groundwork for the versatile, multi-purpose languages that would soon follow and drive innovation across computing. The 1970s brought significant advancements to programming, as languages developed during this decade laid the foundation for both structured and object-oriented programming, two pillars that would shape the industry. In 1970, Pascal was introduced by Swiss computer scientist Niklaus Wirth. Pascal was designed with education in mind, focusing on structured programming principles. It emphasized clear code organization and modularity, making it an ideal language for teaching programming fundamentals. Pascal encouraged good programming habits, which contributed to its popularity in academic settings and set the stage for more disciplined software development practices. Just 2 years later, in 1972, C was developed by Dennis Ritchie at Bell Labs. Unlike many languages of its time, C was powerful, efficient, and highly portable, allowing it to be used for both system software and application development. Its close relationship to machine code made it ideal for low-level programming, such as operating system development, while still being user-friendly enough for general software applications. C's influence would grow far beyond the 1970s, becoming one of the most important languages in history and the basis for numerous later languages like C++ and Java. Toward the end of the decade, in 1978, SQL, or Structured Query Language, was developed. SQL represented a different direction in programming, designed specifically for managing data in relational databases. With SQL, developers could efficiently store, retrieve, and manipulate large volumes of data. As businesses and organizations embraced digital data storage, SQL quickly became essential, laying the groundwork for modern data management and analytics. The 1970s marked a turning point with languages like Pascal, C, and SQL, which brought structure, efficiency, and data management capabilities to programming. This era not only improved programming's usability, but also prepared developers for the increasingly complex software systems of the future. The 1980s was a decade of specialization and expansion in programming languages, with new languages emerging to meet the needs of different disciplines and programming styles. In 1980, Smalltalk introduced the world to object-oriented programming in a big way. Although the concept had been around since Simula in the 60s, Smalltalk made it practical and popular. It introduced key object-oriented concepts like inheritance, encapsulation, and polymorphism, revolutionizing software development. Smalltalk's approach allowed developers to think in terms of objects, representing real-world entities, and making code more modular and adaptable. Just a few years later, in 1983, C++ was developed by Bjarne Stroustrup as an extension of the C language. C++ combines C's speed and efficiency with the powerful object-oriented features from Smalltalk. It was a groundbreaking language that enabled developers to write complex applications with more control and reusability. C++ quickly became popular for everything from operating systems to video games and remains a dominant language in high-performance software development. In 1984, MATLAB was introduced, catering specifically to scientists and engineers, with its powerful tools for numerical computing and data visualization. MATLAB made it easier to analyze large data sets and visualize complex mathematical problems. and it became a staple in fields such as engineering, physics, and finance, where high-level data analysis is essential. Then in 1987, Perl was created by Larry Wall. Known as the Swiss Army knife of programming languages, Perl excelled in text processing and scripting. Its flexibility and power made it ideal for tasks like log file analysis, network programming, and CGI scripting, which were becoming increasingly important as the internet started to take shape. Finally, in 1989, Python was developed by Guido van Rossum, emphasizing readability and simplicity. Unlike many languages before it, Python was designed to be easy to learn and write, with a clean syntax that resembled everyday language. Python's readability quickly won over developers and made it popular for a wide range of applications, from web development to scientific research. The 1980s were pivotal in expanding programming's reach, as languages like Smalltalk, C++, MATLAB, Perl, and Python each brought unique strengths to specific areas of computing. This decade set the stage for modern programming by introducing specialization, flexibility, and a focus on developer productivity, elements that would define the software development world for years to come. The 1990s marked a revolutionary era in programming, fueled by the rise of the internet and a focus on user accessibility and interactivity. It was a decade that redefined how people would interact with technology and laid the groundwork for today's web-driven world. In 1991, Visual Basic was introduced by Microsoft, making graphical user interface programming simpler and more accessible. By enabling developers to create visual applications with drag-and-drop elements, Visual Basic opened programming to a wider audience and transformed software development for desktop applications. Also in 1991, HTML, or Hypertext Markup Language, emerged, giving structure to the World Wide Web. HTML made it possible to build web pages and connect them through links, creating the foundation for the internet as we know it. This simple text-based language allowed anyone with a browser to view and navigate information online, marking the start of the web's explosive growth. In 1993, Ruby was developed by Yukihiro Matsumoto in Japan, combining simplicity and productivity with an object-oriented approach. Ruby's ease of use and readable syntax made it ideal for developers who wanted to write cleaner, more expressive code. Then came 1995, a watershed year for programming. Java was introduced by Sun Microsystems with the goal of making software truly cross-platform. With its write once, run anywhere philosophy, Java enabled applications to run on any device with a Java virtual machine, from desktop computers to mobile phones. This cross-platform compatibility made Java one of the most widely used languages in the world. Also in 1995, JavaScript was created by Netscape, adding interactivity to static web pages. JavaScript allowed developers to create dynamic, interactive websites, forever changing the way people experience the web. Its immediate popularity helped solidify the web as an interactive, multimedia-rich platform. Meanwhile, PHP also appeared in 1995, designed for server-side scripting. PHP enabled the creation of dynamic web pages by processing data on the server side, making it easier to build websites with interactive features like forms, content management systems, and databases. PHP's simplicity quickly made it a staple for web development. Finally, in 1997, R was released as a language specifically for statistical computing and data analysis. R's powerful data handling capabilities and extensive library of statistical tools made it essential in fields like data science, bioinformatics, and academic research. The 1990s was a period of intense innovation that set the stage for modern web programming. Languages like HTML, Java, JavaScript, PHP, and R, along with tools like Visual Basic and Ruby, reshaped the programming landscape, making it possible to create interactive, data-driven, and platform-independent applications. This decade paved the way for a connected world where the web became an essential part of everyday life. The 2000s was a decade of immense growth in web and enterprise programming languages, with a shift toward more sophisticated tools for building dynamic websites, enterprise-level applications, and interactive platforms. In 2000, Microsoft introduced C# as part of its .NET framework. Designed for enterprise applications and web services, C# combined the power of C++ with the ease of Java, making it easier to develop robust, scalable applications. Its integration with .NET made it the go-to language for Windows-based enterprise solutions, influencing software development in corporate environments for years to come. The following year, in 2001, Microsoft launched ASP.NET. This powerful framework allowed developers to create dynamic, data-driven web pages with ease. It enabled the seamless integration of web forms, databases, and user controls, driving the development of interactive websites and modern web applications that could handle complex business logic. In 2003, Scala was introduced, blending functional and object-oriented programming paradigms. Scala's concise syntax and emphasis on immutability made it a favorite for handling complex data processing tasks. It also improved concurrency, allowing for more efficient handling of multiple tasks simultaneously, a vital feature for modern, large-scale applications. Also in 2003, Groovy was developed as a dynamic language for the Java platform. Groovy added more flexibility and ease of use to Java programming by simplifying syntax and introducing features like closures and dynamic typing. This made Groovy especially useful for rapid application development and scripting within Java environments. In 2007, Lua gained traction as a lightweight, embeddable scripting language, particularly in the gaming industry. Its small footprint and easy integration with C and C++ made it ideal for game developers, and it quickly became a staple for creating game mechanics and scripting in popular video games. In 2009, Node.js was introduced by Ryan Dahl. It allowed developers to run JavaScript on the server side, transforming JavaScript into a full-stack language. Node.js brought event-driven, non-blocking I/O to server-side programming, making it an ideal choice for building scalable, real-time applications like chat systems and live updates, particularly in the growing field of web-based applications. The 2000s set the stage for the modern web, providing developers with powerful tools like C#, ASP.NET, Scala, Groovy, and Lua. These languages gave rise to the dynamic web applications and enterprise systems that define much of today's digital landscape, offering more flexibility, scalability, and performance than ever before. This period also marked the continued evolution of programming, with new languages emerging to meet the demands of more complex, interactive, and high-performance applications. The 2010s were a transformative decade in programming, as the rise of mobile development, data science, and functional programming reshaped the landscape of software development. A variety of new languages emerged, each addressing specific challenges in performance, scalability, and user experience. In 2010, Rust was developed by Mozilla, aiming to offer the performance of C and C++ while ensuring memory safety. Rust's focus on preventing memory-related bugs made it ideal for system-level programming, and its speed and safety features quickly gained popularity among developers working on low-level, high-performance software. Around the same time, R gained widespread use in the world of data science, driven by the increasing need for data analysis. R's extensive libraries and statistical functions made it a go-to language for data analysts, researchers, and statisticians, reinforcing the decade's data-driven culture. It became a powerful tool for handling large data sets and performing complex statistical analyses. In 2011, Kotlin was introduced as a modern alternative to Java. With its concise syntax and seamless interoperability with Java, Kotlin quickly gained favor among Android developers. In 2017, it became the official language for Android development, cementing its place in mobile app development as a more expressive and efficient alternative to Java. The rise of data science was further fueled by the development of Julia in 2012. Julia gained traction in numerical computing for its high-performance capabilities and ease of use. Its ability to perform complex calculations quickly made it popular in scientific computing and data-heavy fields. allowing researchers to process vast amounts of data efficiently. In 2014, Apple launched Swift, a modern programming language designed for iOS and macOS development. Swift combined ease of use with high performance, allowing developers to write safer, faster code. With its introduction, Apple set a new standard for mobile app development, offering an alternative to Objective-C with a cleaner, more intuitive syntax. In 2015, TypeScript was introduced by Microsoft as a superset of JavaScript, adding static types to the language. TypeScript's ability to catch errors early in development and its suitability for large-scale applications made it a popular choice for web developers, helping teams build more robust, maintainable web apps. Finally, Elixir gained popularity in 2015, particularly for real-time web applications. Built on the Erlang virtual machine, Elixir focused on scalability and concurrency, making it ideal for building systems that could handle large numbers of simultaneous connections. It quickly became a go-to language for building chat systems, messaging apps, and other real-time applications. The 2010s saw the introduction of powerful modern languages like Rust, Kotlin, Swift, TypeScript, and Elixir, which met the demands of mobile development, data science, and scalable web applications. These languages empower developers to create faster, safer, and more efficient software, laying the groundwork for the next generation of applications and systems. As we enter the 2020s, programming languages continue to evolve, driven by advancements in AI, data processing, and cross-platform development. The focus shifted to improving performance, security, and simplifying development for cloud infrastructure, real-time applications, and system programming. By 2023, Nim and Zig had emerged as important players in the system programming space. These languages prioritize performance and simplicity, providing an alternative to C and C++ for developers working on low-level system programming. Nim gained attention for its ability to compile to multiple backends and provide high-level abstractions, while Zig stood out for its minimalistic design and focus on safety and performance, making it ideal for developers looking to write efficient, system-level software. The 2020s have been a decade of rapid advancement in programming languages, with a strong emphasis on AI, cloud development, and cross-platform support. As languages like Nim and Zig continue to evolve, they reflect the growing demand for secure, high-performance, and easy-to-use tools for modern software development. This timeline highlights how programming languages have transformed from early machine code to specialized tools for today's most pressing challenges, including data processing, AI, and cloud computing. Programming languages are more than just tools. They're expressions of human ingenuity, adapted to solve increasingly complex problems and push the boundaries of technology. From the early symbolic systems that laid the groundwork for all coding to today's specialized languages, driving artificial intelligence, data science, and cloud computing. Each generation of languages represents an essential step in computing's evolution. Reflecting on these innovations reveals a shared drive toward creating systems that are faster, more reliable, and accessible. Each language highlighted here is part of a broader history, with many others also contributing uniquely across different fields and specialized applications. As new languages continue to emerge, they not only carry forward this legacy, but also pave the way for yet unimagined advancements. The evolution of programming languages is a testament to human creativity and technical progress, inviting us to consider how future languages might further transform the way we interact with technology and build solutions that shape the world. If you enjoyed this journey through the evolution of programming languages, don't forget to give this video a thumbs up and subscribe. Your support helps us bring you more content like this. Thanks for watching.